Common sense. Fist bump. Number 3. No. Physics. The physics has to work. Then you're okay. Be clear. That's why mathematicians are miserable bastards. Right? I dated a mathematician because holy shit. With a beautiful weather, like gloomy, you know. You know what I mean? Okay? I'm not saying don't date them, okay? They're fine. Or vice versa. We clear? Okay? You are going to do more of this with 8, with 9, with 10, with 11, 12. You have to combine what? You have to combine most circle the stresses that you have been working on. Be clear? Okay. Now, go back to here. I told you, right? Today's a fun day, yes or no? So much demonstration and not even writing a lot. Coming back to here. So we just completed what? We just completed fracture due to torsion. The next shearing stress is due to shear force. Okay. And this is one of the most complex analysis. If you go to any university, the most they will spend 3 hours on this lecture. The manufacturing and design of aero engine, I did not know anything about shear stress. What did I do? I put a factor of safety or FOS of 2. And I was embarrassed. Okay? Because when they talk about shear stress, I'm not a too. I was embarrassed. That's where I realized that FOS is not as full of shit. You don't know anything, the shit becomes small, you put a factor of safety of what? 10. Be clear? Okay, so you need to know what? How shear force is reacting to your structure. And be very sure about it. Okay? Now, this topic is very easy. Sorry. The formula is very easy. You only have 2 formulas. Okay? You only have 2 formulas. What are the 2 formulas? So the first formula is Q is equal to VQ over I. Okay. And Q is known as the shear flow. Okay. And then you have V is the shear force. You followed by Q is the first moment of area. And I is the second moment of area. Okay. And if you look at Q, the formula is A Y bar. And the units is in meter cube. And if you look at I, it's usually width depth cube over 12. This is meter to power 4. Shear force is in Newton. What I'm trying to do down here is I'm trying to derive the units. So the units for shear flow, so you have Newton meter cube over meter 4. We know that this is Newton per what? per meter for shear flow. Now, visually, what is shear flow? I repeat again, visually, what is shear flow? If we have a cross section of a structure, so I'm going to draw something simple. And the structure, I will put bracket down here, non-thin wall. The shear flow, let's say your shear force starts from the top. If I were to draw our transformation, this is the Y, and this is the Z, this is Vy. What will happen is the shear flow will do this. So this is our Q. Okay. So shear flow, so note the longer the length, the higher is its magnitude. Okay. The longer the length, the higher is its what? Magnitude. Are we clear? So i.e. at the surface, right? Q is equal to what? 0. Okay. So that is what we know by what? Shear flow. Okay. The next thing that I'm going to talk to you about, I think you have seen this before with Dr. Koshi, yes or no? Right? Briefly. Were you all tested in 2 PO4 on shear stress? Yes or no? So you're basically applied that shear stress. Now the next one is shear stress is equal to VQ over what? IT. Okay. The next one is VQ over IT. So for this case, you all know every term where V or T is the thickness of the structure. Okay. And it's in meters. So for that case, tau, which is your shear stress, is in Newton per meter squared. Okay. Now, we are a nation that we love everyone and anyone. So we also work in pounds, inch cube, inch for. Come on, we are University of Inclusivity and whatever PT, you get what I mean? We have to embrace it, okay? I was told. Are we clear? Okay. We cannot do otherwise. Right. Now, the fact that I show you what fracture is all about is I want you all to see how a structure fracture comes out here. If I were to draw a beam now, and this beam is in 3D. Hey. And this beam is built into a wall. Okay. And then we have a shear force. Different color. acting on my Vy. And if I'm going to sketch out transformation, okay. When we calculate the area, right, we know that we have two things to consider. You have Q is equal to A y bar, and you have I is equal to BD cubed over what? 12. Just a general formula. And someone tell me, under shear, where were the surface there? Yeah. Not so much detail. Is it the vertical surface or the horizontal? The vertical surface. So the fracture, why do you say vertical average? No, you did not do that. You did not do that. Why? Anyone? It's okay to embarrass ourselves within these 6 walls. After this, when you go to industry, you don't know any of these will embarrass me. You know what will happen? I'll come up with it. If I work, yeah, I'll come up with it. Okay? So in shear, we tend to think, right? We tend to think, Eugene, I think where failure will occur is failure will tend to occur on this face. Yes? Why we think that way? Because we have the perception on the concept of this. Shear the what? Cross-sectional area. Yes or no? Right? Okay. But I'm not saying that this is wrong. This is correct for this situation and this situation only. Repeat again. This is correct for this situation only. But what we are dealing with is not the same. It's now we have a what? We have a beam. So which direction it will fail? If I were to tell you that fracture now will occur on the, come on, Eugene, on the horizontal orientation. You guys are telling me, Eugene, I want my refund back. Yes or no? So the fracture surface, based on this, okay, based on shear, is the horizontal, is at the horizontal plane. Okay, it's not at the vertical plane. Some people are very wealthy. They have the luxury to show, to do a test, concrete beam under pure shearing stress, and you can see majority of the cracks are running about which direction? Not vertical. Then everyone should be so pissed off, usually. Then why are we looking at the first thing? Why are we looking on the what? Vertical cross sectional area. When Dr. Koshi taught you all, to calculate the first moment of area and the second moment of area, is it looking at the cross-sectional area? Can you recall? Yes or no? It is. But what did I just show you? Fracture occur in the what? Now, why did that happen? Then why did that happen? If you look at this, in order you remember, whatever things, how complex it is, you go back to do what? Fundamental. Is it right to say that the vertical surface did not fail, but it's the horizontal? We go back to fundamental. So when we go back to fundamental, what mental am I talking about? Stress strain curve. It can be shear strain, and shear stress. Okay. What will happen is this surface will go here, and then you will do this, and then you will have what? This is where you have your what? Fracture. Okay. Now, let me ask you a very simple question now. Let me ask you a very... So you need to have what? You need to have a certain what? Fracture what? Strain. Yes or no? You need to have a certain fracture strain. Now, coming back to here, if you look at the cross-sectional area, if I were to push a vertical load down, will the cross-section change its shape? Will the cross-section change in shape in terms of geometry? Now, let me replace the question. If I were to induce a vertical force, the length in the x direction will deform more on the y direction. Repeat again. The length will change more in the x or more in the y. Sorry, the dimension will change more in the x or more in the y. You're doing the right thing. When you bend your finger, your cross-section area at the tip of the finger is not changing. But however, when you bend your finger, it's going. Yes or no? So for that fact, this is why under shear force, the fracture will occur on the horizontal. Then some of you will say, Eugene, again, you did not explain to me why the what? Vertical area. We will continue on Friday.